Okay, our next set of 5 videos are going to be 6 through 10. And let's go ahead and get started. It says graph the function f of x is equal to 1 over x. And then find its domain and range. So with my calculator, I'm going to go to the graphing utility. Let's say I have this pulled up from my last problem. Okay? What I'm going to do is I'm going to delete, and I'm showing you right now on how you can delete graphs in between problems, like on a quiz or a test. From this screen, you can just press delete 3 times, and it will prompt you, are you sure you want to delete everything? And you just say yes. Now press tab to get to your y1. And we're going to graph that 1 over x. So let's go control divide, and we'll put 1 over x, and we'll press enter. And there's our graph. So we have a piece way over here on the bottom and over here on the top. So the bottom left, top right. So if we go back to our graph, we want something that looks like this. Well, A doesn't look like that. B is missing a piece. C is missing a piece. The only one would be D. Now, let me go ahead and draw a quick kind of X and Y axis. And with this graph, you can see, it's a little hard to see the graph, but it is getting very close to the X and Y axis, never touching, and the X and Y axis over here, never touching. And if we were to scan the domain, that means with a vertical line, okay, so let's go ahead and get a vertical line going on. We're going to scan where this function would actually exist. So as I scan left to right, we know it's from negative infinity because that arrow shows it goes to the left forever. But then at 0, it doesn't exist. Then right after 0, it starts to exist again forever. And hence, that's why you see that this domain is going to be negative infinity. Whoops. It will be negative infinity all the way to 0. Open on both because they're not touching 0, and it will never reach negative infinity. And then when union, 0 all the way to infinity. That's what you have in this algebraic notation right here. And then the range, the same thing, but this time we're going to have it with a horizontal line. And when we scroll up, you'll see, so this is domain. Make sure you write this DNR on the test. It's going to be from negative infinity all the way to 0, union, and these are y values from 0 to infinity. And that's number 6. Let's keep going. Alright, so number 7 has 2 functions. It has f of x, okay, and it also has g of x. So here is the machine for f of x, and here's the machine for g of x. Okay? What is f minus g, and what is its domain? So if I'm going to do this without a calculator, which you will have these without a calculator, I need to put what is f of x in parentheses. And then I'm going to subtract whatever g of x is in parentheses. Now remember, I prefer you writing it horizontally like this because it will eliminate mistakes, especially if you probably made them on the quiz. Because you're going to distribute this on all 3 terms. So that distributive property says this will become negative x squared. A negative times a positive is still a negative, and a negative times a negative is a positive. So that's how you get those signs to change. Because there's a positive 1 here, nothing changes. It's still going to be 7x plus 2 because you're distributing a positive 1, which doesn't change those numbers. So now you're just going to combine like terms. You see that I have your 7x right here minus 1x, 7 minus 1. You know it's going to be a 6x. And typically, we try to use the biggest powers to be listed first. Well, this 6x is a positive, so I'm going to sneak in this negative x squared right in front of it. Again, trying to put the highest powers first, and then x to the 1 second, and then our constant last. So this would be the answer. Now remember on the test, like I was showing you, so proper notation, I actually do want you to write kind of like repeating the question, and this would be sufficient. F minus g, or you could have put f of x minus g of x, or even f minus g of x is equal to the following. So the only one that looks like it's going to be the answer, actually I made a mistake, I just realized. You're probably thinking the same. It's not plus 2 because my constants are 8. So the one that looks like negative x squared plus 6x plus 8 would be C. So C is the answer on this one. And the domain is all real numbers. If I were to graph this right here, so my answer basically, if I were to graph it and scan it to see what the domain is, it would actually be all real numbers, all the way to the left and all the way to the right. Just for calculator practice, we're going to look at that real quick. Okay, so I'll press delete 3 times because it's a new problem. I'll press yes, I'll press tab, and then negative, which is underneath the number 3, x squared plus 6x plus 8. There's my graph. It will go to the left forever. Okay, it will go to the left forever. It'll go faster downward, but still nonetheless it's going to be sliding to the left as you keep going to negative infinity. Just like this one, it will keep sliding to the right, very little by little, but forever as you go to positive infinity. So the domain would be all real numbers. Okay, so let's go on to number 8. 8 says the store is offering a 25% discount on all items. Also, employees get a 10% employee discount. So if you are an employee, which discount would you want to be applied first to save the most money? Well, here's the thing. Let's say I have something that costs $100 and I'm getting a 25% discount. That means normally I'm expected to pay 100% of whatever the total price is. But if they're taking 25% off, what I'm expected to pay is 75%. So what I could do is multiply this 100 by 0.75, which is $75, and that's what I'm going to end up paying after this discount. I'm expected to pay this. And then let's say I want to apply this 10% discount now. Okay, so again, this is a 10% discount. So don't multiply it by 0.10. You have to be thinking, okay, I'm normally expected to pay 100%, but then they're giving me a 10% discount, which means I'm going to pay 90% of whatever is there. So from here, I'm going to pay 90% of the leftover $75 that I'm expected to pay. Okay, so just real quick with the calculator, let's say soft mouse, or you can do control left. Notice how I did control left to go back to page 1, and I will do 90%, so 0.90 times 75, and I'm paying 67.5. So 67.5 is what I'm going to end up paying, so $67.50, if I applied it in that order. Well, here's the thing. All I've done is multiplication. And multiplication, order doesn't matter. You can do 2 times 3 is the same as 3 times 2. So it doesn't matter which one I apply first. It's going to be the same result. And I'll show you. So the answer is C. Because had I planned the 10% discount first, I would have started at my original 100. I would have applied the 10% discount, which means I'm expected to still pay 90% of that. And whatever I got from that, I would end up multiplying by these 0.75, because I'm multiplying by the remaining 75%. Either way, you're still going to get $67.50 again, because order doesn't matter with multiplication. Let's show that. So 90% of 100, you get $90. And if I multiply that by 75%, you see that I still get $67.50. So order does not matter with multiplication. All right, so let's keep going. Number 9. How can you tell that the range, y values, of the function shown in the graph cannot be less, so the range cannot be less than -2. So let's say less than -2. What would you do to make the domain -2? So domain is x values from -2 to 3. Okay, so how can you tell that the range of the function shown in the graph cannot be less than -2? So less than -2 range-wise means over here. So not at -2, that's why I have it open, but everything below. And the reason why you can tell is that there's nothing over here. It doesn't keep going. If it did, then it would be hitting these y values. But because it's open right here, it's less than, not less than or equal to, and again, it doesn't keep going. So that's how you can tell from the open circle at y equals -2. And then what would you do to make the domain -2 to 3? So this is a different problem. So if the domain is closed at -2, closed at 3, and everything in between, what I would do to this graph is, number one, I would fill in this open circle. And the other thing that I would do is I would cut it off and not let it continue to the left forever with this arrow. I would actually cut it off and make an endpoint right there at 2. And now there's my graph showing that it's only between -2 and 3. Alright, so now our last problem in this video is number 10. Okay, and then we'll go with the other ones in just a bit. So, is the inverse of f of x, otherwise known as the inverse of f of x, is the inverse of this a function? So we want to know, what is this function? First of all, if I were to go to my graphing calculator and put 3x squared plus 4, control right, delete 3 times, yes, because I want to delete everything, and press tab to open up a new y equals. And we're going to put in our problem as far as our function that we were given, which was 3x squared plus 4. Okay, so here we go. 3x squared, so you can press that x squared button right next to 4, and we're going to do plus 4. So there's 3x squared plus 4. It's basically this kind of shape that goes on up forever and ever. Okay? And what we're wanting to do is the inverse of this a function? Okay? So, like we were saying, we want to find if the inverse is a function. So remember, the inverse will reflect across y equals x. It's that mirror image across as you were folding a piece of paper. So if I looked at this, I could pick, like, let's say 110, which is way up here. So 110, we talked about this in class, would change to the inverse of 10, 1. This is how to do it by hand. And then 0, 1, 2, 3, 4 would turn into 4, 0. And then we could try negative 110-ish, somewhere around there. And it comes out to 7. So that just so that you know. Actually, I probably should do that so not to confuse you. Whenever you put a 1 into this blue equation right here, 3x plus 4, you wouldn't get a 10, you would actually get a 7. So it would turn into 7, 1. So let's go 7, 1, there's the dot. And then if you put a negative 1, you would get a positive 7. So the inverse would be a 7, negative 1. So the graph ends up looking something like this. And you can already tell that it's not going to be a function because it fails the vertical line test. Okay? So let's go back and see algebraically. Actually, I'll just do it from here. I can show you how it's not going to work algebraically. Okay, so we have 3x plus 4. 3x squared plus 4 is the original. You know the steps. The steps are change this to y. That's step number 1. Step number 2 is change the x and y's placement. Okay? So where the x and where the y are, they're going to flip. Just like we flipped with inverses as far as 1, 7 went to 7, 1. Okay? And then last but not least, we're going to try to solve for y. We're going to try to get y all by itself in its new location, because that's going to be our inverse function. So subtracting 4, dividing by 3, and then taking the square root. And careful, when you have a variable that is squared, Okay? Only when you have a variable that is squared and you're square rooting this side, you must do the plus and minus on this side. This is huge and very important. A lot of people forget this. So y would be left over here all by itself, and it's a plus or minus x minus 4 over 3. Which, yes, our last step, since we were given it as f of x, is to write it as the inverse of f of x is equal to plus or minus x minus 4 over 3, all square rooted. Now, the reason why people forget this plus or minus is because they're not remembering that anytime this number is an even number, 2, 4, 6, 8, doesn't matter, you have to account with this plus or minus. Because it's like saying this: x squared is equal to 81. Well, most people would take the square root of both sides and think the answer is only 9. But it's actually, when you do this with the variable here, you have to do the plus or minus on the right side. So plus or minus 9 is actually the correct answer. Because if I were to plug in a 9, a positive 9, back into my original equation here, I'd have 9 squared is equal to 81. That works. But if I also plugged in negative 9 in parentheses, that too would work. Okay? So you're going to have two answers, not just one. Okay, so and visually, just to let you know, this positive version of all of this stuff is this piece right here. Whereas the negative version of all this stuff, meaning it has negative y values, is going to be all this stuff down here. Alright, so the answer would be no, because it would fail the vertical line test. Alright.